Guys, you could fail. Hang on this. Mark them.
48, 49, 50. Good. All right. So we're going to start today by talking about the different methods we've used, or we could use, to measure the flagpole, which eventually we'll do when the weather's not -9. Suggestions? Yes? Is not a method for measuring the height of the flagpole. Strike one. No, you can't do Strike two. Will not help you measure the height. Trig ratios. Could you be more specific?
Sine, cosine.
Yeah, I know what the trig ratios are. How would you use those trig ratios to measure?
You have like the length, like where you're
Okay, here it is. Give me a play-by-play method that I'm going to go outside and measure that flagpole.
Okay. So if you were standing, like say, 50 feet away from the flagpole,
How would you know that?
you would measure it.
With? A ruler? 1, 2, 3. You'd use a ruler?
Or like a yardstick, that could work too.
A yardstick?
A measuring tape.
Measuring tape?
Or a measuring tape?
Yeah.
Okay, so you're 50, what'd you say, yards or
I
feet?
said feet.
Feet, 50 feet away. Okay, you've positioned yourself 50 feet away from the flagpole.
Well, you would need at least one angle. Which, I don't know.
Okay, I'll give you an angle. There we go.
You need, oh, I know that, but you need another angle, it's not.
So we need 2 angles.
Yes.
That's not what you said. You said we need a angle.
You need 2 angles.
You need 2 angles. Where are we going to get another angle?
Well, you could, wait, you have to draw a line from where you're standing to the top of the
How would I do that in the real world? Patrick?
Can you find the angle of elevation?
How?
Well, it's like one of those angle measures, handy dandy.
Okay, so you have one of those handy dandy angle measurers. Okay. For our purposes, that handy dandy angle measurer will actually be a straw taped to a protractor, but we'll get to that later. And what would you do with that handy dandy angle measurer?
You could find the angle of elevation from your eyes to the top of the flagpole.
Are you one of those guys that's gonna lay down and put your head in the grass and measure from the ground, or are you gonna stand straight up and measure the angle? Neither one is incorrect. Just personal preference.
Depending on if it's like a nice day, I'm not laying on the ground.
Okay, all right, hold on, let me fix that then.
Oh no.
Okay, so you've put your eye in the grass, and using your handy dandy measuring device, you're gonna measure the angle of elevation up to the top of the flagpole. We'll call that angle theta. It's about time you guys learn your Greek letters. Then what? Gesundheit. Go ahead.
Then you can find the other angle by the
Sure.
yeah.
What do you wanna call that other angle?
Q.
How about beta? You were close. Okay? That's great. How tall is the flagpole? Hey, Tommy. Excuse me 1 second, kids. Tommy wants to take his test. Go ahead, Patrick.
You can use the tangent of
Okay.
that one letter. The circle one.
That's the theta. Okay. The tangent of theta.
And we can call the height of the flagpole x. or-
Okay, we'll call the height of the flagpole x. Since your eye is down on the ground, we don't need to add that extra height in there. Okay.
So it would be tangent of that one letter.
Theta.
Theta.
Right. Rhymes with beta.
Wait, is it theta or
Theta.
Theta?
Theta. Theta.
Wait, I have a question.
Like feta cheese, but pronounced differently and spelled differently. Hold on, we're not done yet.
So that would be, it'd be the opposite, side measure, which would be x over 50.
Beautiful. Simple calculation, right? From a practical standpoint, what's going to be difficult with the system that you have in place?
You don't necessarily know the exact measure of the angle elevation.
Well, but we could get a pretty good estimate using one of our fancy dancy protractors with a straw tape to it machines. Nick?
We don't know what theta is.
Well, we're gonna find theta, he's gonna measure it. He bows his head in shame.
It's like defeat.
No. Is there any part of this that you couldn't do right now? Ignoring the fact that you put your face in some cold snow.
Right now, you wouldn't be able to find the hypotenuse.
Do we care? No. Okay. Good strategy? Okay, it's a possibility. I like it.
But you can find the hypotenuse.
Yeah, we can find the
You can, sure, if you're feeling saucy, but it's not anything that we need, because all we really want to know is the height of the flagpole. Okay, that's one strategy. And by far, probably the most common strategy that people would use. $48, $49, $50. Okay. Other techniques. Carter.
You could do the notebook or piece of paper one where you line up the two corners.
Excellent.
of the flagpole.
You could stand here, put a notebook up to your face, which wouldn't look strange at all, and line it up and do that calculation. Which one, Carter, do you think is more accurate, the notebook or the face in the grass with the straw attached to the protractor technique? How difficult do you think this is going to be?
Protractor.
Yeah, that's a little tricky, but still a viable method. We could measure that. What else do we need to know?
You need to know the angle. I don't know how you find it. From like the top portion. Of the
You need to find this angle?
No, the
This
bottom
angle.
left at the top triangle.
Bottom left at the top triangle.
Well,
That angle?
yeah.
Don't need it. The nice thing about your method is you don't need any angle measures. Because you already have a 90-degree angle. There is one other measurement we need. What is it?
Your height.
Your height. You need that measurement. And then you can go and do that calculation. A little tricky because holding a 90-degree angle up to your eye, and then you have to position it so that the top lines up with the top of the flagpole and the bottom lines up with the bottom, can be a little tricky, but still a viable possibility. That's two methods.
Couldn't you just do that with knowing your height and knowing how far away you're standing from the flagpole?
48, 49, 50. Huh?
Couldn't you just figure that out with just standing, knowing how far away you're standing from the flagpole and your height? Because you wouldn't really need the angle.
Okay, so your question, if I'm hearing you correctly, is if I know this distance,
Yeah.
let's say it's 50 feet, because we used our ruler to measure it,
Yeah.
and you know your height, how tall are you?
5 feet.
Okay, good, that's a good answer. That's nice round numbers. You're saying that's enough information to figure out the height of the flagpole?
Yeah, I
Ow.
think so, because 50 would be the altitude, and then you could do the chunk method, and then, yeah.
No, because that would only work if you know there's a 90-degree angle. Remember, in order to use that technique, you have to have two right angles here. There's got to be a right angle up here and a right angle up here. Just because you're 50 feet away doesn't guarantee that the angle at your eye is going to be 90 degrees.
Oh, okay.
Okay? But we're on the right track. There is another method there. Galen?
The shadow method.
Beautiful, shadow method. We don't actually need this distance. we need to know two things. What are the two? Well, actually, we need to know three things. What are they, Caleb?
Your height, the shadow of you.
The shadow of you. Sounds like a pop song
I was about
title.
to say, it
doesn't it?
sounds like
Justin
sounds like a
Timberlake
Taylor,
song.
yeah, Taylor Swift or a Justin Timberlake song.
And then the shadow of the flag.
Shadow of the flagpole. Okay. And you can be standing anywhere. You know, and then you got the shadow of the flagpole, wherever that is. And then shadow over height equals shadow over height. Good. What's the problem with that? Any problems with that technique? Yeah.
It might be a little hard to measure the shadows.
Yeah, like today, not gonna work so well. Not very sunny. Jack?
The shadow will keep moving.
Well, yeah, but not, yeah. I mean, if it takes you 4 hours to measure the length of the shadow, it is gonna move a little bit, but it's fairly negligible. Carter?
Kind of be impossible to get to the exact spot, so
But it doesn't matter where you go.
wouldn't, like, let's say, right all the way over there, wouldn't
Doesn't
the
matter.
sun be at a different angle?
Yeah, but again, it's negligible. You're right. From a pure physics standpoint, it would be a slightly different. I mean, if you wanted to be more accurate, you would want to line yourself up so that the end of the flagpole shadow matches up exactly with the end of your shadow, and then but if you use that technique and then I go over there and stand and measure it, it's going to be fairly. I mean, you're talking about measuring a shadow in
Yeah.
some grass that, you know, might be off a couple inches. Okay. What is that? Is that 3 or 4 techniques? 3. Okay. So we're going to use all of those when we go back outside. But today's lesson involves a simple conundrum. What happens if you can't measure some of the things that we've used to find the height? So for instance, let's suppose I want to measure the height of a mountain. Okay, so this is level ground, and then on the ground, I have a mountain. And there are a couple things you can't measure about the mountain. The biggest thing is that I don't know, this is the peak we're going to measure. I can't figure out where is that point at the bottom of the mountain. So that screws things up a little bit. So we're going to use a different technique here. And here's how it works. We come over here on level ground, we'll call this point A, and you measure the angle up to the top of the mountain. We'll call that angle theta. And for our purposes, I'm going to actually get rid of the mountains so it doesn't confuse people and reduce it to a triangle. But understand that we can't measure this. We're actually looking for that, but we can't easily measure it. We'll call that H. Then I back up some distance. It doesn't matter. The distance you back up is completely irrelevant. We'll say for our purposes I back up 2 miles down the road. And I remeasure the angle to the top of the mountain. We'll call that beta. By the way, a beta is like a fat capital B with a tail. Which angle's bigger, theta or beta? Wait, hold on, let's change the angles. They sound too similar.
Oh, yeah.
Let's use gamma. Fish standing on its head. This will be easier. Which one's bigger, theta or gamma? Theta, correct. Does everybody see that? All right, good. As you get closer, the angle will get bigger. How am I going to calculate the height of the mountain from just that information? So I would know what theta is, I would know what beta is. In fact, let's ignore the Greek letters, let's put some angle measures in here. Let's make that 25 degrees, and we'll make this 35 degrees. Alec, what do you got for me?
Is it the same, like the same kind of problem with that movie theater one, where we didn't know how to do that equation?
The movie theater one.
Where like it was drawn out the same way. That
Yeah,
yeah.
yeah, it's similar.
Yeah. Wait, yeah.
Michael.
Yeah, shouldn't that be, yeah, shouldn't that be bigger?
Oh, yeah, they should be switched, sorry. Thank you. I thought all of you were having an epiphany on how to solve the problem. You're just pointing out my mistakes. Thank you. Good. Glad you guys are paying attention. You passed the first part of the quiz.
Yash passed.
Way to go, Yash.
Wait, what happened? Yeah.
Huh? You did great.
You just took the rabbit hole.
All right.
Now you can see how far the rabbit hole
Nick?
was.
Okay, so there's a relationship, is there a angle to angle and side to side ratio?
No,
Okay.
because the triangles aren't similar. Caleb? That's it? That's what you're gonna say?
Well, I was gonna say like, since the triangles are similar, but they're not similar.
Right. Nate?
Could you find the measure of the triangle, of like the angle at the top in the 35-degree triangle? And that would be 90 minus 35, which is 55.
Okay, so you want that angle measure is 55. I'm with you.
Then you could do the bigger angle measure of like 25 of the triangle. Like the same angle.
I assume you're talking about this angle?
Yeah.
Okay, how big's that angle?
65.
65. Okay,
And
which
then-
I can do the math in my head would mean that that's 10 degrees.
Yeah,
I like that. So what?
and that's all I got.
Oh, good, good, good. It helps. Any other ideas? For discussion purposes, let's call this distance x. And that distance is the point from where you started to that imaginary location at the bottom of the mountain. Well-
You use like the sine or tangent or something, does he have 35?
Can we narrow that down a little bit? The sine or the tangent or something, which one?
Tangent,
Tangent, all right.
because you have 35, you can find the opposite and adjacent sides.
Okay. So give me a couple equations here then.
The tangent of 35 is h over x.
Love it. Is that solvable?
No,
Why not?
it's too big.
And how many equations? Four. Okay, not solvable. But if we can come up with the second equation, yes, sir?
Would you be able to do tangent of 10 degrees?
No.
Okay.
And that brings up a good point. Why can't I use the tangent of 10 degrees?
It's not.
You answered your own question. Actually, you answered the question that I asked that you presented with the question that you started by.
Yeah.
Right, it's not a right triangle. Nate?
You can do tangent of 25 is equal to h over x plus 2.
Hot diggity. Okay, here's the bad news. That's the easy part. Solving that is a little tricky, and that's what we're gonna spend most of the time on. Before I move to the next screen, are you okay with the setup here? You understand what we're doing?
Yeah.
The first equation that Wilma gave me came from this blue triangle. Straightforward right triangle tangent calculation. The second equation that Nate gave me came from the bigger triangle and is also a straightforward tangent calculation. Nothing fancy going on there. We have two equations, we have two unknowns, that should be solvable. Solving it, however, is the difficulty. So let's do that. Slide number 2. Tangent of 35 degrees was h over x, correct? And the tangent of 25 degrees was h over x plus 2. All right, how are we gonna solve that? Hmm? Technically it is a system. We've got two equations, we're looking for two unknowns. What method would you like to use to solve that system?
Yeah. Would you multiply it by x, but negative?
So, what, guys,
Would you multiply it by negative?
what's it?
The
Both equations by x?
No.
No.
Wait,
Oh, yeah? Oh,
I don't know. Right. This is.
Jacques?
Once you just solve for one variable, so for example, h, multiplied by x,
Are you asking me or telling me?
I'm telling you.
You're telling me to solve for one variable and you chose h.
Yeah,
Outstanding.
the h,
Okay, so if we take this first equation, I solve for h, what do I get, Jack?
h equals tan 35, wait, x tan 35.
Good. Keep the x out in front so it doesn't get confused.
And then,
Now, you might be saying to yourself, why can't I just take the tangent of 35 and go from there? Because we want to keep the answer as accurate as possible, so we're going to leave the tangent equations in there until the end. Second equation?
h equals, x plus 2 tan 25. And then set those equals.
What's wrong with what I just wrote? Emma?
It's saying that it's 2 tan 25 plus x.
Right.
Parentheses.
Thank you. Big difference there. Without the parentheses, as Emma said, we're talking about x plus 2 times the tangent of 25. We want x plus 2 times tangent of 25. Back to you, Jack. What do I do next?
Set them equal to each other.
Awesome. And this is where the hilarity ensues. What next, Jack?
Oh, wait. Oh, okay. Subtract.
Nope. Rich?
You might need to distribute tan 25 to both.
You might.
X, so we got.
In fact, that would be a solid approach.
Yeah.
I just have a question.
Certainly.
Can you do tangent 35 minus tangent 25?
No. That's a good question. Be careful when you're working with trig equations or trig functions because they don't work like normal functions. The tangent of 35 minus the tangent of 25 is not the tangent of 10 degrees. Okay, we're making headway. What next? Sarah, you raising your hand there or just itching your nose?
Yeah.
Or scratching your nose? You're not itching it. No? You're not itching your nose, so you did have a question?
No,
You had an answer.
Yes, I don't have a question.
No, you nothing.
No.
Okay, good. Yes, sir.
Do you multiply, you said, by the
No.
tangent and no, I'm very sure of that.
Nope. Jack?
Subtract.
Okay, that's a bold statement. Subtract. There's a lot of things I could subtract.
X tan 25 to x tan 35. So we get x tan 10.
You started out strong and then you faded. No, you don't get x 10, 10. It's tangent, by the way, not tan. Okay, correct. Now, what did we do there? We took all the x's and moved them on one side, just like same procedure you used to solve all the other equations. In fact, you get all the variables on one side. Carter.
Factor out the x.
Nice. Factor out the x.
Yeah.
This is not subtractable. So you have to factor out an x. We've seen this before. I should say this technique before. Yeah.
Divide by 2.
Nope. Yeah.
Divide by tangent 35 minus.
Yeah, divide by that mess to get x by itself. You know what the worst part about this whole calculation is?
What?
Doesn't even answer the question. This is only x. Doesn't tell us how tall the mountain is.
Well, then
At
you
this
start-
point, I have x isolated. Now you pick up your handy dandy calculator and you plug this in and tell me what the number is. However, be aware of the fact that you're going to want to put that bad boy in parentheses. Nick?
1.355.
That's not what I got.
No.
No.
Okay.
Oh, I made two down, you like hit vipers.
I got,
What?
I got
Six.
0.6. Is that, wait, I got
I didn't-
0.7.
No.
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 Carter?
I got 3.99.
3.99? Yes?
Yep.
Yes? Yes.
Oh.
No.
Should have.
No. Anybody else? Yeah, 3.99?
Yeah.
Nicola, 3.99? Yours is messed up? Why? How do you what's messed up? Is it, are you in the right mode?
Oh, I know.
And nobody's messed with your calculator?
I also got
3.99. Okay.
Yeah, it's in degree.
Which of course you would store in your calculator because we're gonna need that to finish the calculation. That tells us how long x is. Now, in a problem like this, also when you're measuring the height of the mountain, sometimes the idea of the simple question, does that answer make sense, kind of goes out the window. Probably an answer like what'd you say, 0.7?
Yeah.
Probably not gonna be accurate, you're too close. You'd actually be under the mountain.
I actually did it again and got 3.99.
All right.
Can we go through that?
Can we go through how to get that
How
calculation?
do you plug it in your calculator?
2
Yeah.
times the tangent of 25
If you actually do it,
divided
you
by
just say second
parentheses.
to
Are you listening, Nick?
Yeah, I'm looking at his calculator as you say.
2 times the tangent of 25 divided by parentheses, tangent of 35 minus tangent of 25 close parentheses. Now be aware on your calculator, I believe on the 84s, it automatically puts a parenthesis in here, doesn't it?
Yeah.
So you gotta be sure to close it. So it would actually be tangent of 25, close parentheses, because it stuck one in there, divided by parentheses, tangent of 35, close parentheses, minus tangent of 25, close parentheses, close parentheses.
So you have to close it every time.
Because otherwise it continues on everything else you type in, it still thinks it's taking a tangent of that big mess.
Okay.
Okay, so then we go back to the other screen and see that if we know x, we can then find h easily by, I would take the top one, the tangent of 35 is equal to h over 3.99. Of course, you're going to use the stored information, not the approximation of 3.99. And it turns out that the height of that mountain is Gesundheit. Why is that sneeze so funny? Did you spit all over yourself or something? Did you get some in face hair?
No, I don't know.
Once we stop recording, remind me, I'll tell you a story about Doug from
Wait, we're
5th
recording?
grade. Yeah. Patrick,
I got 2.79
can somebody confirm?
Yep.
What are the units here?
miles.
Miles, because we started with that. I have no idea what the normal height of a mountain is, so we're gonna go with it as being somewhat reasonable.
That's pretty.
Depends on the mountain.
Yeah, it's a somewhat large amount.
That is a
Yeah.
very large
It's
mountain.
like
That is
about
almost
Would
half-
definitely not be a hill
Isn't that half of,
or a berm.
Well, you
how high is, Mount Everest?
It's like 24,000.
Yeah,
it is.
yeah.
It's kinda big.
This is half
Okay,
Mount Everest.
any questions? This is gonna pop up a lot. Couple things to be aware of. Number one, make sure you carry the tangent values all the way through the problem.
It's almost.
Again, looking at my
No, it is half.
calculations here, I did not plug in for the tangent values until the very end of the equation when I had that big honking value for x. Also be careful when you plug numbers into your calculator, make sure you got the parentheses correct. It is much easier, believe it or not, to solve for x and plug it back in to find h than it is to solve directly for h, but you could solve directly for h. That's 4 different techniques now to find the height of the flagpole. We'll get a 5th technique tomorrow when we talk about law of sines and law of cosines.
K2.
Who's the comedian? Is that you, Sebastian?
I thought today was Friday.
It is today. Friday is
It is
today.
Friday.
Right, I made an error.
Oh,
Yeah,
I seriously thought today was Friday.
Oh, you weren't just being a comedian.
No, I actually thought that today was Friday, and then you said there's tomorrow, so then I thought it was Thursday.
No, Thursday you had off of school.
Yeah.
You didn't come here
I got it.
yesterday,
I'm
did you?
confused on that day.
So we're good now?
We're
good.
Okay, excellent. Any questions on this before I erase? Yes?
Well, it's not on this particular problem, but it's related to what we were doing earlier. I was like wondering this the whole time we were using like the Greek letters. Is there a song for them?
There has to be a
Can I
song
ask
out
a
there.
math question?
Yeah.
Certainly.
What
But you
was
never-
H?
I'm sure somebody at some, make up your own song to remember the letters.
No, I don't know.
I've never heard of a song remembering the Greek letter. There's not an A, like, you mean, is there a Greek letter song like like A, B, C?
Look it up on YouTube.
Probably.
You could probably make up your own song.
Look
There's
it up on
definitely
YouTube.
Well, see, I only know like the ones that you.
It wouldn't not be a song.
Okay.
Yeah,
Um,
Josh, what was your question?
What was the height of them?
Oh,
2.79.
2.7, whoops, wrong way. 2.79. Okay. Are we good? Excellent. Let's take a look at, wait, let me stop recording
This
first.
song-
Delete.
You gotta tell us the story.
Hold on.
It's like college.
Yeah.
That was not.